Hello students. Now in this lecture we are going to learn about concept of plane. Plane in 3 dimensions. This is a intermediate first year paper 1B chapter 7. Based on that we are going to learn the concept of plane. Okay. Paper 1B Telugu Academy Maths. Okay. So paper 1B Telugu Academy Maths, the plane chapter 7. What is a plane? A non-collinear 3 points makes a plane. Suppose if they are collinear, they make a line. If they are non-collinear, they make a triangle. This triangle can be tilted in any form. It can be tilted along x-axis, y-axis, z-axis, or if you see this plane, it is expanding in all the axes. Okay, so this is an example of plane. This is another plane. Some other tilting angle with respect to the origin. This is some other plane. So we have a plane with 3 non-collinear points. So 2-dimensional points which are non-collinear. Which are non-collinear, 2-dimensional point. As the third dimension is 0, it represents a plane. Suppose S is here, then this point is not in the plane. Suppose S is here, it is in the plane. So we take a point here, N. Is N point on the plane? No, because its another dimension is more. So if suppose you let us say Z is 0, X, Y, Z is 0. That means this is a plane of XY plane. This is an XY plane. Here the third dimension is 0. Suppose Y is 0. Y is 0. Then it represents a plane of XZ. So you can have all 3 dimensions X, Y, Z, but the third point is on the plane itself. Suppose if it is above this point, then it is not on the plane. So let us understand this plane through mathematical equation. Let us say this point is x0, y0, z0. Any point on the plane. There is a normal here. This is the normal. DRs of normal is ABC. DRs of direction ratios. Earlier we have learned about direction cosines and direction ratios. So DRs of the line is ABC. So now this line and this plane, they are perpendicular. So their dot product is 0. So what is the vector of QR? If it is x0, y0, z0, or can be any arbitrary point, or can S also any arbitrary point. Let it be x, y, z, a point on the plane. It represents a point on the plane. So x minus x0, y minus y0, z minus z0 are the DRs of the line on the plane. These are the DRs of the lines on the plane. So these two are normal. Any line on the plane is normal to this. So the dot product A into x minus x0, B into y minus y0 plus C into z minus z0 is equal to 0. This is the equation of the plane. When we have DRs of the normal and we have any point on the plane. So we do these two conditions knowing. One is the perpendicular DRs we know, one is a point on the plane we know. Then so we can write the equation in the form A into x minus x0 plus B into y minus y0 plus C into z minus z0 is equal to 0 because that product is 0. Suppose I am multiplying this. What happens? This is AX, this is BY, this is CZ. So A into x0 is a numerical. A is a dr and x0 is also point. Is a coordinate. X0 is a coordinate. A is also a direction ratio is a number. So number into number plus B number into number, C number into number. So whole thing becomes a number, a constant D. So an equation representing whenever an equation is given ax plus by plus cz plus d is equal to 0, then we can say that A, B, C are nothing but drs of the normal. So this is in the form of drs of the normal, where what is D? D is nothing but ax0 plus by0 plus az0. It's a some constant. So let us see the other condition to write down the equation of a plane. We know the shortest distance from the origin. Shortest distance from plane to the origin is given. Let the shortest distance be P. So what is this point on the plane? If this is P, the x coordinate will be suppose LMN or its DCs. This line DCs are LMN. Here we are talking of DRs, direction ratios ABC. DCs is what? How we can say DR? How we will get DC from here? A by square root of a square plus b square plus c square. B by square root of a square plus b square plus c square. C by square root of a square. These are the DCs. So similarly, let them be L, M, N. So what are the coordinates of P? L into P, M into P, N into P. So this is the coordinate of the P. So this point P is on the plane. And normals we have LMN. Normals we have LMN. So again same. Any point you take x, x minus LP, y minus LP, MP, z minus NP. These are the 3 points. X minus LP, y minus MP, z minus NP is the direction ratios of the line on the plane. So when we do dot product with my direction ratios of the line, this is LP. The coordinates are LP, MP, NP. So I can put L also. I can use DC also here, but I'm putting L. LP M into X minus LP plus MP into Y minus MP, NP into Z minus NP. Yes, what is this LP? LP is representing direction ratio A. MP is representing B and NP representing C. So A into X minus X0 plus B into Y minus Y0 plus C into Z minus Z0 is equal to 0. So here X0 and Y0 is nothing but LP, MP, N. So when we convert this, what I am getting? Lx plus My plus Nz. This is L into X. Lx, P can be cancelled out. 0 is there. So P gets cancelled. Lx plus My plus Np is equal to P into the sum of unit vectors. L square plus M square N square is equal to 1. So P. So we can write with respect to DC's normal, the equation is Lx plus My plus Nz is equal to P, where P is the normal distance from the origin. In place of L, we are using here Ax plus By plus Cz is equal to D. So from here itself, we can see that L is nothing but A by square root of A square plus B square plus C square. M is nothing but B by square root of A square plus B square plus C square. N is nothing but C by square root of A square plus B square plus C square. And D is nothing but P. P is nothing but D by square root of A square plus C square. And that is the distance between the origin and the plane. Okay, let us see this proof also next. Let us see another form of equation using 3 non-collinear points. Let x1, y1, x2, y2, x3, y3 non-collinear points. Let's say ABC are DRs of the norm. So we can write ABC with respect to x1, y1. A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Similarly, I can write with these two ratio x2 minus x1, y2 minus y1, z2 minus z1 is also a dr of the line. So again same a into x2 minus x1, b into y2 minus y1, c into z2 minus. Again d, another x3 to x1. So a into x3 minus x1, b into y3 minus y1, c into z3. See, we are given all x1 point, y1 point, z1 point, x2, y2, z, x3, y3, z. These are numbers. This is a number, this is a number, this is a number, because the points are given. Only this is any equation. X, we are taking any arbitrary point x on this plane. So we have to solve for ABC here. You can solve normally or we can use the matrix method. So matrix method, this is the our x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z. Similarly, this when this matrix is 0, we get an equation in the form of x. So that is my equation of the plane. As every first degree, suppose x plus y is equal to 10. So this is a line. Similarly, if it is x plus y plus z is equal to 10, that means this is a plane. This is simple understanding with comparing with respect to line. So this is the matrix form. How we got this matrix form to solve these three equations? Let us understand that how this form has come into picture. I keep it here. Okay. Let P Q R. So we know PQ is x2 minus x1, y2 minus y1, z2 minus z2. This is PQ vector. Okay. Let it be x2 minus x1 be a1, y2 minus y1 be b1, z2 minus z1 be c1. Similarly, vector PR, x3 minus x1, y3 minus y1, z3 minus z2. Let them be a2, b2, c2. Okay. What is the normal vector to this plane? Is equal to PQ cross PR. Normal vector to this plane is PQ cross PR will give normal vector. So I am finding out PQ cross QR. So IJK PQ. PQ vector is A1, B1, C1. A1, B1, C1, where A1 is this, B1 is this, C1 is this. And P2 vector is A2, B2, C2. So I into B1, C2 minus B2, C1 plus J into C1, A2 minus A1, C2. J into C1, A2 minus A1, C2. Normally, sometimes we put minus J. I into B1, C2 minus B2, C1 because center minus J into A1, C2 minus A2, C1. It is all the same. Whether I put minus J here or plus J and calculate from next column, it is all the same. So plus J into C1, A2 minus A1, C2 is equal to minus J into A1, C2 minus A2, C1. Both are same. So I am putting plus J. Plus J into C1, A2 minus A1, C2. Similarly, plus K into A1, B2 minus A2, B1. But we have assumed in the first instance, ABC are the DRs of the normal. So what is the equation of DRs of the normal? If these are the DRs of the normal, so DR normal DRs is AI plus BJ plus CK. So that means A is equal to B1 C2 minus B2 C1, B is equal to A2 C1 minus A1 C2, and C is equal to A1 B2 minus B1. So then the equation of the line is equal to A is the dr into x minus x1 plus B into y minus y1 plus C into z minus z1. Is equal to 0. So this is whereas A is nothing but B1 C2 minus B2 C1. Here we have found out, we have equated these two because this is my normal vector. This is my A, this is my B, this is my C. So the same thing is, if you see here, this multiplication. A is B1 C2 minus B2 C1. What is B1? B1 we know. We have abbreviated B1 Y2 minus Y. C2 is Z3 minus Z1. So Y2 minus Y1 into Z3 minus Z1 minus B2 C. So this is nothing but this is the matrix. Both are same. This derivation is nothing but same matrix. So what we have done here, we have taken one vector here, we have taken one vector here, and we have done the cross product to get the vector along the normal, and we assumed A, B, C are the vector along the normal. So A into any point x minus x0, x in place of x0, I'm putting x1. So this is the first point. X minus x1, y minus y1, z minus z1. This is A. A is what? Y2 minus y1 into z3 minus z1 minus z2 minus z1 into y3 minus y1. This is A. So A into x minus x1 plus B. Y minus y1 into B is z. You remove these columns. Z2 minus z1 into x3 minus x1 minus x2 minus x1 into z3 minus z1. This is B. So B into y minus y1 plus C into z minus z1 is equal to 0. So this is the understanding of the equation. This is a simple form of the equation. So whenever we get 3 points, it is simply let us make a matrix and solve it. This is A. Automatically we get A here. We get A here. Otherwise we have to go for normal process. So let us convert plane to normal form. This is ax plus by plus cz plus d is equal to 0, the equation of a plane. So we know a by square root of a square plus b square plus c square is equal to L, b by square root of a square plus b square plus c square is equal to M, c by square root of a square plus b square is equal to N, p is equal to d by square root of a square. So this is a normal distance. So it is just simple proof. So let us see. Let Lmn be the DCs of the normal. And P is the perpendicular distance from the origin. So that means LP, MP, and P are the point on the system. So A is the DRs, DR is LP, MP, NP. So LP into X minus LP plus MP into Y minus MP plus NP into Z minus NP is equal to 0. So this equation is LX plus MY plus NZ is equal to P. This is what we have arrived at. Lx plus my plus nz is equal to p. This is the normal form. I want a general form. This is a general form. I want to convert into a normal form. So now I have to find out L, M, N, and P. So these two equations are same. So when I compare them, L by A is equal to M by B is equal to N by C is equal to my P by minus D. P by minus D. It can be equal to some constant K also. So when I equate a square plus b square plus c square, what I'm getting d square by p square into L square plus m square plus n square, which is equal to 1. Which is equal to 1. So what is d by p or p by d? P by d is plus or minus 1 by square root of a square plus b square plus c square. So you substitute here. L is equal to a by square root of a square plus b square. In place of p by minus d, I'm putting plus or minus this. So L is equal to a by plus or minus a by square root of, this is the my vector, sum vector. Similarly, M is equal to B by N is equal to C by, and P is equal to, when P by minus D is equal to L by A, root of A square plus B square plus C square. So P is equal to D by square root of A square plus B square plus C square. You see here, P by minus D is equal to L by A. So A getting cancelled, 1 by this. So when D goes here, D by this. So this becomes minus or plus D by square root of A square. So this is the shortest distance. So P is the shortest distance is D by square root of A square plus B square plus C square. From this equation, what is the shortest distance from the origin? It is nothing but D by square root of A square plus B square plus C square. It has to be a mod D. Mod D. If it is minus given also, plus we have to give. So this we have converted from a general equation to a normal equation. If I multiply with P everywhere, I'll get LP plus MP plus NP. These are the DRs of normal. So AX plus BY plus CZ is equal to P square. P square is equal to nothing but square root of A square plus B square plus C. Okay. So let us understand. We have seen now two forms of plane. One is three forms of plane. One is a normal and a point. Second is distance from the origin and the point. We know distance from the origin. Here only one parameter we know. What is the parameter we know? Shortest distance from the plane to the origin. That's all we know. With one parameter, we are able to find out the equation of the plane is Lx plus My plus Nz is equal to P. This is with respect to coordinate. Okay. Now, this what we are writing. We know two point parameters here. One is the point on the plane, and we know drs of a perpendicular. We are given drs of a perpendicular. Okay. Third equation we know given 3 points are given which are non-collinear. If they are collinear, automatically this will reduce to a simple x and y equation. One will be 0. This is a converting form we have learned. Now we understood another form of plane, intercept form of the plane. We know that for a line, x by a plus y by b is equal to 1 is the intercept form of the line. When y is 0, x is equal to a. When x is 0, y is equal to b. It is simple line like this. And we convert into a equation, line equation. Y is equal to mx plus c. M is equal to minus b by a. Okay, this is a line form. Same thing we are extending to our plane form. Suppose this plane is there, ABC is cutting at the axis. Suppose if it is cutting at x-axis means what? Y and z are 0. So A, 0, 0. If it is cutting at z-axis means x and y are 0, 0, 0, C. 0, B, 0. So let these 3 points are given. We have to find out the equation. We know the normal equation of a plane, Lx plus My plus Nz is equal to P. P is the shortest distance. So when I substitute these points here, A0, because these 3 points also lie on the plane, so this becomes L is equal to P by A, M is equal to P by B, N is equal to P by C. So if I'm putting this instead of Lx, x by A plus M by B, Y by B plus Z by C, PP is getting cancelled. So I'm getting, this is the equation. X by A plus Y by B plus Z by C is equal to 1. Like I have a line equation, x by A plus Y by B is equal to 1. Here, Z by C gets added. Because the points are in 3-dimensional coordinates. X, Y, Z is equal to 1. This is not a dot product. X into A plus Y into B plus Z into C is equal to 0. No. This is a equation when intercepts are there. How we got this equation? We know in normal form. And we compare these two equations. We substituted all the 3 points. I got L is equal to P by A. So when PP getting cancelled, P is nothing but normal distance. I don't know what is this distance, but I know when I put X, Y, Z, the points, I get A, L is equal to P. So L is equal to P by A. So PP getting cancelled. Now let us understand angle between two planes. Is it in figure here? Angle between two planes. Suppose these two planes are there. What is their angle? If we superimpose here, this plane will be going like this. There is some angle between the planes. So it's nothing but simply dot product. I have to take a dot product of cos theta is equal to, what is the dot product? I dot I, j dot j, k dot k survives. All other get cancelled because cos 90 is 0. So I dot j will be 0. I dot k also will be 0. So a1 a2 plus b1 b2 plus c1 c2 is the dot product divided by, we have to reduce it to unit vectors. So this, in fact, of this should be a unit vector L1, M1, N1, L2, M2, N2. How we convert L1, M1, N2? We have seen here square root of a square plus b square plus c square, square root of a square plus b square plus c square. So we have to convert into unit vectors a1, a2 plus b1, b2 plus c1, c2 divided by square. What is the sum of this? Square root of a square plus b square plus c square. What is the sum of second vector? Square root of a2 square plus b2 square. So what we are doing, we are converting into unit vectors first, then we have to applying cos theta. Otherwise, we can straight away write with drs. a1 a2 plus b1 b2 plus c1 c2 by this is the length of the vector. This is the length of the vector. Okay, this is the way this equation. This is the angle between two planes. So we'll be doing examples on all these concepts. What we have learned to consolidate, we're doing the examples. Let us see small examples. Find the equation of the plane if the foot of perpendicular from origin is given. 1, 3, minus 1. So this is a perpendicular is given, from the origin point is given. You know this is LP, this is MP, this is NP. So the DRs of the normal are 1, 3, minus 1. So let's take any point x, y, z on the plane. This is one of the point. So x minus 1, y minus 3, z plus 5 are the DRs of the line on the plane. So dot product is 0. So 1 into x minus 1 plus 3 into y minus 3 minus 5 into z plus 5 is equal to 0. Is the answer. Otherwise, you can put in a central form LP ax plus by plus cz is equal to d. So LP is 1, so 1x, MP is 3, so 3y, NP is minus 5 5z is equal to p square, p into p into p into p, root of a square plus b square plus c square. What is 1 square? 1 plus 9, 10 plus 25 is 35. So p square is getting root of 35 into root of 35 is same. So we can go both way. We can go from the fundamental way, or we can directly write the based on normal DR's equation. Ax plus by plus ez is equal to d. D is nothing but p square. You see in here? Ax plus by plus ez is equal to p square. Because here I'm putting everywhere I multiply with p. So I'm getting the DRs of the normal. So this is nothing but d. P square is d. Let us see another example. Reduce this equation to the normal form. So we know LMN we can find out 1 by square root of 1 square plus 2 square plus 3 square, that is 14. So L is 1 by root 14, M is 2 by root 14, N is minus 3 by root 14, and D, the distance is 6 by root 14. So the answer is x by L, Lx. Lx is 1 by root 14. Lx plus My plus Nz is equal to D. What we have done, we have converted them into unit vectors of the. These are the DRs of normal. 1, 2, minus 3 are nothing but DRs of normal. Once we know DRs of normal, what are the DCs of normal? 1 by square root of a square plus b square, 2 by square root of a square plus b square plus c square, minus 3 by square root of a square plus b square. and distance from the P is 6 by the root of the square. So we can convert into DC normal equation. In fact, if you see 14, 14, 14, everything getting cancelled, what is left over? Same is left over. X plus 2y minus 3z is equal to 6. Same equation. Just we have added root of square in the denominator to convert them into a normal form. This is in the DR's form. This is in the DC's form. Direction ratios of normal and direction cosines of the normal. Okay. So intercepts on axis are given. Equation x by a plus y by b plus z by c is equal to 1. So you rearrange the denominator, you multiply with 4, 4x plus 2y plus z is equal to 4. That is simple. You multiply the LCM. With LCM, you multiply the top. Okay? Let us see another example. Intercepts of the axis of the plane this is the equation given. We have to find out the intercepts. A, B, C. Let x by A plus y by B plus z by C is equal to 1. These are the intercepts of the form. So that means if these 2 goes to here, minus 2, I am putting right side 1. So minus 2 comes to the denominator. Then what will become? This becomes 2x, minus 2x. So x by minus 1 by 2 plus y by, this becomes y 3 by minus 2. So minus y by minus 2 by 3 plus z by 1 is equal to 1. So the same equation we have written in this form. Actually, this 2 is in the denominator, 2x. What is this equation? Minus 2x minus 3 by 2y plus z is equal to 1. So what I want in this format. So what are the intercepts on the axis? X intercept is minus 1 by 2, y intercept is minus 2 by 3, and z intercept is 1. So find the DCs of normal to the plane. It's simple. These are the DRs. So 1 by square root of 1 plus 4 plus 4. Root 9 is 3. So 1 by 3, 2 by 3, and 2 by 3. These are the DCs normal. What is the distance from the origin? 4 by 3. Okay. Once we understand the concept, basically we can directly do the problem. We need not by heart. L is equal to plus or minus a by square root of square by square. Here this we are converting DRs to DCs. Simple. Okay. Equation of plane passing through this point and normal DRs are given. Simple. A into x minus x1, B into y minus y1, C into z minus z1. So A is 3, 3 into x plus 2 minus 5 into y minus 1 plus 4 into z minus 3 is equal to 0. So this is the let us see here. Angle between the planes. We know a1 a2 plus b1 b2 plus c1 c2 by their sum of the vector. So we got this 1 into 3 plus 2 into 3 plus minus 5 into 2. 1 into 3 plus 2 into 3. No, this is D. 2 into 2 plus 2 into 2 divided by what is the sum of this vector? 1 plus 4 plus 4. Root of this is 3. So this is 3 What is the sum of this? 3 square plus 3 square plus 2 square. That is root 22. So cos theta is equal to 13 by 3 root 22. So theta is equal to cos inverse 13 by 3 root 22. So we convert them into DCs and we apply plane angle dot product. So we found out L1. Similarly, typically, we found out M1 and N1. So we applied in the equation. Or we straight away seeing from this, we can A1 A2 plus B1 B2 plus C1 C2 by A square plus B square plus C square by A2 square plus B2 square C2 square. Okay. So where do I, this is the, let us see this. Equation of a plane parallel to this plane and passing through this. Parallel to this plane and passing through this. So since it is parallel to this plane, that means D will be varying. All slopes will be same. X, Y, and Y, Z are same. Only D will be varying. So you substitute here. You get D as 6. So the plane is X plus 2Y plus 3Z is equal to 6. Simple. Otherwise, what are the DRs normal to this? 1, 2, 3. So 1 into X minus 1 plus 2 into Y minus 1 plus 3 into Z minus 1 is equal to 0. So when we substitute also, we are getting same. Now we see the another problem. Perpendicular to x-axis and passing through 2, 3, 4. Perpendicular to x-axis and passing to 2, 3, 4. Let the equation, the normal form is L into x minus x0 plus m into y minus y0 plus n into z minus z0 is equal to 0. So for x-axis, which is perpendicular to x-axis. Perpendicular to x-axis means what? Say, this is x-axis. The plane is like this, vertical. Plane is, this is not perpendicular. If we bring it to the vertical top, the plane is perpendicular to x-axis. So, what are the, this is the normal form. So, suppose, what are the DCs of normal for an x-axis? What are the DCs? DCs is Mn is equal to 0 and L is equal to 1 for x-axis. This is, how is x-axis defined? 1, 0, 0. These are its axis, the DRs. So DRs of normal to this plane or DCs of normal to this plane is 1, 0, 0. L is 1, M is 0, N is 0. So 1 into x minus 2 is equal to 0. So x is equal to 2. So what is x is equal to 2? You put x here, from here it is 2. You put a vertical plane. So x is not varying throughout the infinite plane. Only y and z are varying, but x is fixed at 2. So similarly, if it is perpendicular to y-axis, then y is equal to 3. If it is perpendicular to z-axis, then z is equal to 4. Simple. So we have used the DCs of axis. Perpendicular x-axis means what? This is given DRs of the perpendicular to the plane. Perpendicular to y-axis, perpendicular to the plane. So DRs, x-axis DRs are y and z coordinates are 0. That means 1, 0, 0. Because L square plus M square plus N square is equal to 1. So x is equal to L is equal to 1. Let us see another problem. show that this is a plane perpendicular to xy plane. Perpendicular to xy plane. Now this we are writing in the intercept form. Now we are writing in the intercept form. What I am getting? X by a plus y by b is equal to 1. So there is no z coordinate here. That means no intercept on z axis, showing that it is parallel to z axis. It is parallel to z axis. That means it is perpendicular to xy plane. See, if this is z axis, x, y, z, if it is parallel to z, suppose if it is parallel to z axis, like this, it is not interfering with z axis. That means what? This is xy plane perpendicular to xy plane. Xy plane is the bottom one and parallel to z axis. That means it is perpendicular to. It is all the same. When you talk perpendicular to perpendicular to xy plane or parallel to z axis, is the same. Because there is no z coordinate. But you see, this is one method of understanding. But once you know, equation of the plane is given. So what are the drs of normal of this is 2, 3, 0. These are the drs normal to this plane. And equation of x perpendicular to xy plane. Perpendicular to xy plane. So equation of xy plane is z is 0. So drs of normal to the xy plane are 0, 0, 1. What are the normal like 0, 0, 1? Let us see the both normals, drs of this plane, drs of xy plane. Then I am going to do dot product. 0 into 2, 0 into 3, 0 into 1 is 0. So that means xy plane and the given equation are perpendicular. So this way also we can do. So drs of what are the dc's of xy plane? 0, 0, 1. Perpendicular. Normal to the xy plane is 0, 0, 1. Okay. So let us continue the problem solvings on plane, the three-dimensional plane, class 11, chapter 7. Okay. Let us see. 7A chapter 2.4. Find K as the two planes are perpendicular. So we know when they are perpendicular, their dot product is 0. So 1 into 2 minus 2 into 5 plus k into minus 1 is equal to 0. In fact, theta divided by square root of a square plus a1 square plus b1 square plus c1 square, square root of a2 square plus b2 square plus c2 square also will come under that. But since this is 0 perpendicular, so this get cancelled. So we are not putting that vector sum of these two. So we are directly dealing with drs. K is minus 8. So we got k now. Now asking find plane which is perpendicular to these two planes and passing through another point. So now let us find out the perpendicular to these two planes. Drs of perpendicular. Drs of perpendicular to plane is 1, minus 2, minus 8. K is minus 8, 2, 5, minus 1. So drs are perpendicular to above plane. Now, what are the drs of? Now we do the cross products. These two cross products. So I into 2 plus 40 plus j into minus 16 plus 1 plus k into 5 plus 4. So this is the DS, or let ABC be or normal to DRs of the required plane. Let ABC has the normal to DRs of the direction ratios of the required plane. So both are same. Both are same. So this is the DRs of perpendicular to the planes. This is the DRs of normal to the plane. So A by 42 is equal to B by minus 15 is equal to C by 9. Let it be a constant. So then the equation with these DRs and passing through 1 minus 1 minus 1. So A into x minus 1 plus B into y plus 1 plus C into z plus 1 plus C into z plus 1. If I put K here, so I put A is 42K, x minus 1, 15K is equal to 0. So KK getting cancelled. So I get this is the required equation which is perpendicular to both the planes. See here. See in this thing, let us understand the concept here. See what are 1, minus 2, minus 8? These are the DRs of perpendicular to this plane. 2, 5, 1 DRs of perpendicular to this plane. So we are finding these two perpendiculars cross product. So we get a thing which is parallel to the plane, which is also perpendicular to the plane. It is also perpendicular to the plane. Let ABC be the perpendicular to the plane. So these two are same ratios. So A is A by 42, B by 15, C by 9. Because these two are same. AI plus BJ plus CK are DRs of normal to the required plane. The same. So perpendicular, we get perpendicular. Second way part, we are taking a perpendicular ABC. So we are comparing this to AI plus BJ plus CK. We got this. This K is different from this K. Minus 8 is different. This is, let us say, instead of confusion, let us put it as some P. Okay. So these are all P. P getting, of course, getting cancelled out. Equal to 0. In 0, it gets cancelled. Okay. Now let us go to another example. Find the equation of the plane which passes through this and perpendicular to the joining of the line. So what are the DRs of this line? DRs of this line is minus 2, minus 1, minus 3, 3, minus 2, 1, 4, minus 3, 1. So this is passing through this and perpendicular. That means these are the normal to this plane. So we have a normal and we have a point A into x plus 1, B into y minus x, C into z minus 2 is equal to 0. So this is the equation. Let us see. Bisecting the line segment and perpendicular to it. So when we are bisecting means we get the center point. 2 minus 6 by 2 is nothing but minus 2. This is minus 2. 2 minus 0, 2 by 2 is 1. 6 minus 4, 6 plus 4, because this is a bisector. So 2 plus 0 by 2 is 1. 6 plus 4, 10 by 2 is 5. So this is the point on the plane. Is a point on the plane. And bisect and perpendicular to it, that means I get DRs are, what are the DRs? Minus 6, minus 2, minus 8, 2 minus 0, 2, 4 minus 6, minus 2. These are the DRs normal to the plane and we have a point on the plane. This is a standard equation. So automatically he has given the center point and he has given the DRs. If line DRs we know and perpendicular to it means this line is perpendicular to the plane. So the perpendicular line to the plane, perpendicular to the plane line, the DR is same. Okay. Now, before going to further, I will just recapitulate. First, DRs and DCs revision. Let us have some revision. Let us take a line, vector line. So this is a vector line. Okay. And the coordinates here are say 1, 1, 1. And coordinates here are say 2, 5, 6. So this is a vector A, B. So vector A, B. So this is A. This is B. Now we know vector A, B. What are the DRs? DRs is x2 minus x1. So 2 minus 1, 1. 5 minus 1, 4. 6 minus 1, 5. These are the DRs. So what are the DCs? DCs means for a unit vector. This is converting to a unit. That means what is the sum here? What is the vector sum? What is the distance between these 2 points? Is 1 square plus 4 square plus 5 square under root. So 1 plus 16 plus 1, 17 plus 25, 42. This is root 42. Is the distance between these two. So I want a distance of 1 meter. What is a distance of 1 meter? What is the value of dr? So I'm cutting this into DCs. That is 1 by root 42 4 by root 42 5 by root 42. So these are nothing but LMN. This is L, this is M, this is N. What is L square plus M square plus N square? 1 by 42 plus 4 by 16 by 42 plus 25 by 42 is equal to 42 by 42. That is 1. So these are the sum unit vector is 1. That means if I want to show a unit vector here, I'm increasing this is the unit vector. In this direction, between xyz, xyz, this is the unit vector. If I multiply this unit vector with my value, scalar value, distance between them, I'll get the full vector. So understand? So this is the dr, this is DC between 2 points. If this plane is there, suppose if a plane is there, so this vector is perpendicular to this plane, and we have point 1, 1, 1 on the plane. So the equation of the plane will be what? So the dot product is 0. So here L, or you can write dr itself 1 into x minus 1 plus 4 into y minus 1 plus 5 into z minus 1 is equal to 0. So this is the equation. Here this dot product we make, but divided by we'll get root 42, but that is 0 side it goes becomes 0. So we remaining, this is the equation. So let us do the problems with this basic knowledge. Revision of our TRs, and because this earlier chapter is an important chapter. Let us see this problem. Find the equation of a plane passing through this and perpendicular to these planes. Again, we have done this perpendicular to the plane and passing through the point. It is same thing. So when passing through this means what? Let A, B, C be the normals directly, DRs. So A into x minus 4 plus B into y minus 4 plus C into z minus 0 is equal to 0. So we get this is the point. This plane is perpendicular to these two given planes. So what are the DRs of the perpendicular line? 2, 1, 2 and 3, 3, 2. So when we do the cross product of this plane and this plane, what I'm getting? 2a plus b plus 2c is equal to 0. 3a plus 3b plus 2c is equal to 0. Now I'm solving this ijk 212,332. What is this 212,332? This is 2, 1, 2, 3, 3, 2. I'm solving ABC here. So I into 2 minus 6, j into 6 minus 4, k into 6 minus 3. So I got this. Comparing the equations, what are my direction ratios? AI plus bj plus ck. So a by minus 4 is equal to b by 2 is equal to c by 3. So when we substitute this in my equation, a into x minus 4 plus b into y minus 4 plus c z minus 0, because the point of 0 is a 0 point, z minus 0. So I got my equation. Otherwise, what is this ijk pattern? Let us take the same equations. 2a plus b plus 2c 0, 3a plus 3b plus 2c 0. So here if I eliminate c here, if I delete c is eliminated, so 3a minus 2a is a, 3b minus b is 2b. So a by minus 2 is equal to b by. We get a relation between a and b. If I remove b, I get a relation between a and c. So between these three, I'm drawing a relation. If I divide it by minus 2, so a by 2, a by minus 4 is equal to b by 2. So a by minus 4 is equal to b by 2 is equal to c by 3. This is nothing but same what I got here. So instead of solving in this way, we solve in the ijk format. So this is I component is a2 bit b2c2 b2c3 minus b3c1 b3c this is c3 na? b2 c3 minus b3 c2 because I component j component. So a by 4 b by 2 c by 3. This is nothing but solving, simply solving and bringing out the relations. If we are not familiar with this equation, not confident, you can go this way also. Okay, let us see. Equation of a plane passing through 3 points. We have this in passing to 3 points. The dot product is a cross product we have to make. So equation passing through, let us say 2, 2 minus 1. A into x minus 2 plus b into y minus 2 plus c into z plus 1 is equal to 0. This is the equation. Now, on this plane, the other 2 points also exist. Other 2 points also exist. So in place of x, I am putting x, y, z, I am putting 3, 4. In place of this, I am putting 7, 0, 6. Both I am substituting. So I got one equation here, I got another equation. 2 equations in A, B, C. So if I eliminate C, I'll get an equation in A and B. If I eliminate B, I'll get an equation A and C. So this is same way, this way. So what I'm getting here, a by 5 is equal to b by 2 is equal to c by minus 3. This way I'm substituting in this equation. So a is equal to 5 into x minus, suppose let it be k. So 5k into x minus 2 plus 2k into y minus 2 minus 3k into z plus 1 is equal to 0. So k get cancelled because 0 is there. So k is now become irrelevant. So this is how we solve. So what we have done here, we have taken one point and made an equation. If these 2 points were submitted in the equation, I got a relation between ABC. And this ABC relation used to form the. But this is not the method we learned here. What we learned here? For 3 points, this is the matrix method. It's a matrix method. So let us do one example on matrix also. Instead of going matrix method, I can do simple method also. Once I know this relation, basically this relation comes from matrix method. A is what? A is y2 minus y1 into z3 minus z2 minus y3 minus y1 z2 minus z1. Same thing happens here. I do all the solution, equation is direct. So let us see this. We got 3 points, the 4 points. We have to prove that they are coplanar. So first 3 points I'm putting in as a part of equation. X minus 0, y plus 1, z minus 0. This is the first point. And this is x2 minus x1, y2 minus y1, z2 minus z1. And this is x3 minus x1, y3 minus y1, z3 minus z. With all points I'm relating to point number 1. Second point to 1, these are direction ratios. Third point to 1, these are direction ratios. X minus x1, this is any point, general point x, a into x minus x1, this is a direction a. We got a, this becomes a and z. Now we'll go to next slide. When I solve this equation, this matrix, what I'm getting, this is the equation I got when I solve this matrix. This matrix. X minus 0, x into 2, this is the matrix component. X into 2 plus 2 plus y plus 1 into this plus z into 4 minus 2. So this is the equation. Now I am checking whether the 4th point is on this plane or not. I am substituting the 4th point. I got the same equation is valid. That means the 4th point is also lying on the plane. So in this problem, we have done one is we have found the equation using the matrix method from the formula, or we can find from this also. We got 3 points, we can find from this also. Both are same. This is a formula method. This is a basics from the basics. Let us see. Passing through these 2 points and cutting off intercepts whose sum is 0. So let the intercepts be ABC. So a plus b plus c is equal to 0. Intercepts on the axis. A plus b plus c is equal to 0. Now we write the equation in the form of intercept form. So here, point I substitute this point. I get a relation between ABC. I substitute second point. I get a relationship A, B, and C. Point 2. So when we are adding, these two are getting cancelled. 6 by A is equal to 1, 2. A is equal to 3. So from this we know B plus C is equal to minus A. So B plus C is equal to minus 3. So when we use B plus C is equal to minus 3 in this equation, I am getting 2 values of B. It's a quadratic in B. I'm getting 6 and minus 2. When I substitute 6, A3, B6, then C will be A3, B, A is 3, B is 6, 9. So C is minus 9. When I put A3, B minus 2, 3 minus 2, 1, B is minus 1. So this is C value. So these two equations, x by A plus y by B plus z by C, solving. And for second set of values, A is same, B, C changes. So we have two equations for the same set of points. So how we have proceeded here? We have proceeded using this formula and substitute and solve. Okay, now let us see. A plane needs coordinate axis at ABC whose centroid is ABC. So let the equation be x by a1 plus y by b1 plus z by c1 is equal to 1. That is the equation. A1, B1, BC1 are the intercepts on ABC. Now, what is A? Centroid is 0. Let A is A1, 0, 0. B is 0, B1, 0. C is 0, 0, C1. So centroid is A plus B plus C by 3. So A1 by 3, B1 by 3, C1 by 3. This is centroid. So that means A1 is equal to 3A. So I substitute A1, B1, C1 values here, and 3 goes to the right hand side. X by A plus Y by B plus Z by C is equal to 3. So this is the answer. Now, show that the plane passing through these three is parallel to y-axis. Parallel to y-axis. Now, plane pass. Let us say drs of these two lines. 1 minus 1, 0. Minus 1. Minus 1 is minus 2. 1 minus 1, 0. We got 0, minus 2, 0. So drs of AB is x and z plane is 0. This is y plane only exists. So y is minus 2. That means this is parallel to y-axis. Or you can have a second method. This is a concept method. DRs are between some DR I am getting that the z and x-axis are 0. DRs of AB. So this is normal. This is the show that the plane passing through this. This is a plane. This is a plane DRs. So this is parallel to y-axis. Y is minus 2. Let us see the other method. Again here, I have 3 points. Now I forming the equation of the plane. From the equation, I get 3x minus 4z plus 1 is equal to y component is 0. What are the DRs of normal to this plane? 3 minus 4, 3, 0, minus 4. 3, 0, minus 4. What are the DRs of y-axis? 0, 1, 0. So these two, when I do dot product, I am getting 0. That means perpendicular to this plane is perpendicular to y-axis. That means plane is parallel to y-axis. So with this lecture on plane is on. We have to do more and more examples so that we can get a good grip on the subject.